Acadèmics, acadèmiques, senyores i senyors, bona tarda, benvinguts a la sessió d'avui, en la qual el doctor Rodrigo Martins, acadèmic corresponent, ens parlarà sobre el tema Emerging Advanced Materials and AI to Answer the Sustainable Society Demands. Per dir-ho així molt ràpid, el doctor Rodrigo Martins és catedràtic d'Enginyeria de Materials a la Universitat Nova de Lisboa, és director del board del clúster portuguès de materials avançats i de les bateries, és expert en nanotecnologia, materials funcionals avançats i microelectrònica, és autor o coautor de gairebé 1.000 articles que han rebut més de 35.000 cites i és un dels autors de la tecnologia Paper Electronics i autor de 58 patents. Actualment és president de la European Academy of Science. El seu currículum és molt més llarg, força més llarg, i per tant l'aturo aquí. I li passo la paraula a ell, que és molt més interessant que no escoltar-me a mi. Dr. Martins, is your time.
So, first of all, it's for me a great honor to stay in this fantastic place under your leadership, Mr. President. And what I will try to share with you on this, my first lecture here, that I believe we can share. Next one is some of my work that I did and try to explain how the new tools that we have could help us to give quantum jumps in favor of getting better prosperity in a sustainable way for the people. So that's what I would like to share with you. I would like to start by giving you an example. How was the world 45 years ago? And 45 years ago, the communication, to communicate with the people, we use paper. Paper to educate, paper to read the news, paper to establish the communication in our offices. And even at our home, we have the CRTs, which was just a box that projects an image in a fluorescent tube that gives us a picture. So nothing was really interactive with us. Let's look for the world today. When we go to look for the world today, what we saw is the interface to communicate the information is an electronic display. This is the interface that we are using in the office to educate the people. Even we created new things that will impact on our strategy. And I'm very proud because I'm also part of what was generated. Is something that I show here is what we call transparent electronics, which means that I can make electronics fully transparent, which means what a big challenge at that time is how I can make out of a wide bandgap material something that works like a semiconductor. And this is something that is not amazing at that time, but is the real thing that we have today on medical chirurgy applications. Why? Because when you have a chirurgy, you have typical 2 or 3 doctors, and they need to communicate to each other. And on this, you have a transparent display where, from both sides, they can see and follow what is going on. This is a strong jump that we did. And there are other things, which is even more important. Everyone uses today. Maybe they cannot go farther without GPS. Today, we have this GPS that are impregnated in our cars, and this display are based on this technology. So, means that I would like to show you how we progress in 20 years or so and reach something that is really important for our life. So this means that this is the digitalization for greatest achievement. There are no doubt. I used to count one story here, is that the great invention that we did was energy. We need energy to move, to create, and to generate our factories. But beyond this great invention that is due to Edison and Tesla, maybe we know better Edison than Tesla, we have internet. Today, to communicate the information, we need internet. And internet started with a need. You can find in Europe, you always find someone that said in 1980, between my university and the other university, we communicated and blah, blah, blah. Okay, this is typical the European position. But to establish a real strategy to communicate and pass the information long distance was a need that started in CERN. Because people in CERN needs to communicate with the colleagues in USA, and then they have to think. In 1998, they launched the first attempt to make this type of communication and in real time to exchange data. And this was established, it makes 25 years this year. That's why we will commemorate in Geneva this at the end of this year, because it means that when you have a need, you create a response. And this was generated not by engineers or electronics, but by people that at that time we call, they are looking for basics of the science. So, and this is something which is very important. So it means that this achievement, that is how I can disseminate and pass the information, is our great challenge of this century. And the ways how we can do it is really fantastic. But as you can see, I have to create things that could serve a lot of communities. And then it means that I have to imagine how I can build the new systems, the new technologies that will impact on us. And then, as an engineer has a ruler to understand better, to make calculations, we invented AI and the digital twin. And this is something very important because we emulate the behavior of a physical system by a virtual system that is able to take data itself and to update itself along its life cycle. What this means? It means that during his real-time data acquisition, he is able to optimize and generate itself actions that is impossible someone to do on very close time. So this is our great tools that we have today. And of course, this type of strategy is basically what we have is we have in one side, we have the physical-based models that I want to develop. And for these models, what I need is database. So the great business in the future is how I can exploit and have credible database that allow us to go further. And of course, I need, with respect, mathematicians. Because we need mathematicians, because are the ones, we need to identify algorithms. We need to establish what is the algorithm that makes the interconnections, and I have to have credibility. So besides, I need to have physics and engineers also working, because I need to understand how I can interpret the data that I'm generating. So indeed, this is the three blocks that I put. I have the database. The database means that I need sensors. And this sensors means that I need to have what is the prevision of how many megabytes I'm able to do. By 2025, we expect to reach something like around 175 zettabytes. 1 zettabyte means 10 to 21 bytes. This means, just an idea, 36 million years of HD video frames. Impossible. So you can see how fantastic is this machine, because it makes in short time what is impossible in a lifetime to do it. But the basis of everything is the algorithm. So that's why I said I need mathematicians to do this type of interchange. And at the end, we have the computers. Of course, the computer means that how many frames per second they do. Look, this is around 2 to 20 to 10 to 18 flops per second. This is impossible. It's below our imagination, the time that is consuming to make each operation. But of course, with all of this, we need energy. And this is the great challenge that we have today, is that if I install a supercomputer able to apply on this with these virtues that I'm putting here, the consume of energy is by far larger than what all Barcelona town consumes. This may be close to a medium town in China with 5 million people or so. And this is why you see how the great companies that are exploiting AI to give these big jumps like Amazon and so on, they are saying, I need energy. I need to power my supercomputers. And then what people are doing is building or rebuilding nuclear plants. And I think this is not the correct way. What we need is this is a challenge. We need to use ultra low power electronics. We have to mimic the nature of our brains that consume a lot. They make lots of operations consuming very few energy. This is the neuromorphic. So this is the synapses that we have to looking for. And this is really a challenge because on this type of memory registers that everyone is trying to develop, to consume is 4 orders of magnitude smaller than a CMOS, which means that we may be in the right track. So this is a challenge, and not to say, if I need energy, let's use it and try to see how I can get it. Of course, when you are on this new century, where, as I told you, we are working in the name of the people and for the people, it means that all this type of commodities that I spoke with you has to serve to the people. So it means that we are exploiting to the limits our natural resources. And this is, if I want to make the same, with the same performance, is natural. I have to use much less material. If I have to exploit, so when we speak in nanotechnologies, in nanoscale materials, it's evident that this is what we have to use it if you want really to satisfy this type of needs. So nanotechnologies is a must from us. And then, of course, above all these commodities needs energy. And we need energy in different ways to power our towns, to power our commodities, to power our industries and our factories. And of course, as the interface, as I told you, is electronics, then we are generating exponential electronic waste. And how we can recycle this electronic waste? Today's all the electronics technologies is based on the king of the kings, which is silicon. Silicon is the most abundant material. But when you go to look for silicon, you have some constraints. Some constraints that put Europe in danger as far as prosperity is concerned. Because when we go to look for microelectronics, silicon-based, I have to dope. This means I use very dangerous gases like phosphine, diborane, silane. And when I go to exploit this technology, I need to use large amounts of energy, above 1200 degrees centigrade, to transform the silicon. This generates CO2. And so means that if we look for sustainability, it means if I want to produce a lot of commodities for the people, I need to go for something that could be recyclable, reused, and to process them to use minimum energy as possible. And this means that we have to go what we call emerging technology. And otherwise, of course, draining the planet Earth. This is the figures that I have for 2024. I don't make the actualization, but you can see the amount of CO2 that we are creating. Just for you to have a simple idea that, for instance, a supercomputer that I told you before, the CO2 that produces is equivalent per day to 125 flights between Frankfurt and New York and return. So it means that we have a problem of sustainability here that we have to do. And of course, we have also to take care about the increased rate that we have. When you go for power consuming in our everyday life, this is the spectra where we have maybe, I have here 10 nanowatts, maybe we have to go down to 1 nanowatt process systems. But you can see the plethora of energy consuming commodities that we have going. And at the end of here, I show the needs of energy to power a town or to power an airplane. Our dream is to have, in the near future, an electrical flight, as we took 50 years ago when we make the first transport Boeing, or like Boeing airplane. And this means that with this 1 gigawatt that you need to power an airplane, the weight needed for batteries, because we are speaking on batteries, with today's technology, means that is above 500 million tons, which means the airplane cannot lift off. Impossible. This happens if you see the famous movies in the past where when they try to make the first Boeing plane with TWA, it happens like that. So this is again a challenge. What is the challenge? We need to make batteries more lighter. So we need to look for materials, we have to look for low power consuming, but of course we have to have low weight batteries in the future. Okay, when you go to look for power electronics for comfort and welfare of the citizens, we have to look, as I show you in my first slides, the number of electronic devices that we need. GPS is one of them. No one today may survive without it, but you have a plethora of people that are exploiting and using this interface to communicate and to control. In average, we have something around 13 devices per people. I tell you, Samsung makes every year 500 they have to sell. So they are creating rubbish, so it means that circularity of the things are very important. And this is also very important, that if I have to serve the people, which today we are over 8.15 billion people in the world, it means that if you look for this type of commodities, by 2050, so 30 years from now, or around this, 25 years from now, we may need more than 100 billions of these commodities. So we generate exponential a lot of electronic waste. So it means that for this type of applications, we have to look for the emerging technologies. This is what we call responsible consumption and production, which is one of the goals, objectives of the United Nations. And of course, when we have to go for our challenges, see what we have today. We have overpopulation, over-consuming. No one has just one system, it's more than one system. We are using, today we have this wars, we are using critical raw materials and fossil-based resources, which we have to move. We have a war in Europe now due to this. And of course, all of this, when we try to develop and we don't care about how we can transform our materials, we have pollution and contamination of our resources. But of course, the key issues are over-consuming, minimum waste to recover, and use of critical materials are the demands of our days. And what we have today is, this is what we are creating. We are increasing the generation of electronic waste in a very high rhythm. And what we have, our thinking, and most of our industries, they think, how I can make money. This is the prosperity. So we have high levels of disposable incomes at the towns, because it's where you have the comfort and you have everything that you need. And of course, you have the industrialization able to create this type of commodities, and then you don't care. You don't care how you close the circle. And I think that all of this is the demanding that we have of high electronic products, short lifetime of the components, and no repair. We have just to revert the circle, and on the right side, look differently and look for complementary functions. Otherwise, how we can imagine our planet that is green as we use, but we are destroying our planet. This is a critical message. And this means why it's very important when we make research, and most of us are researchers, we have to think greener. What means greener? Greener means that we have to generate the technologies and select the materials that are compatible, what we call with circularity, recyclability, and processing at low temperatures. And I like to recover something that I think for all these developments, the core are materials. And in 2005, it appears this reclam from George Clooney. He said, no martini, no party. And I and Renzo Tomellini, we say, no martini, no materials, no party of science and technology. And this is true. And we fight for exploiting, saying that we need materials to build our future. And to build our future means that whatever you look for ITCs, I need to see beyond silicon. What are the emerging technologies that can really impact? For agriculture process, I need to have sensors able to test and control, because we need to supply the food, the needs of food for a huge amount of people. And we have to control this. And for energy, I need to find energy sources that are non-pollutant and could be sustainable. And this means a lot of things that goes from how I produce the energy, how I store the energy, or I transform the energy. And this was how we thought. Then when you look for biotechnology on the health sector, again, you need to see nanoparticles. You have to imagine how I can create it, a lot of cures, a lot of problems that we have with diseases, how I can control it. In the electronics is normal, even for aerospace and aviation. As I told you, I have to find new lighter materials. I have to supply energy in much lighter systems. So I have to move from the silicon technology for other ones. I will repeat this. And for robotics, for manufacturing technologies, as I told you, and for transportations, we have to create the materials common hub. We gave this example in 2005, and we say, let's fight for something that we need together. And I'm very proud, because after more than 20 years around this, we built it, we got it. We have now the initiative in advanced materials innovation that I'm the founder. This begins with this idea, how we can aggregate together to make something else. And this is the first program that we have, as far as I know. But I'm a little bit old. There are others, but never in Europe. You create an association that is controlling the scientific program. You have had spirit programs, bright programs, we have leading people, but it was not an association controlling the program. And this is what we have today. So, in this respect, what are the strategies that we are thinking for the future? And based that, no materials, no party of science and technology, okay? So, we have to design new materials. That's why we need AI and devices with ultra low power consuming. This is a message. And we have a project here with ECN just on this matter. And of course, the main strategies to be followed is to look green materials, which means abundant and eco and human friendly. Green technologies means simple technologies, affordable for everybody. I can make it out of clean rooms and low power consuming. And this we satisfy the objectives, the sustainable objectives of the United Nations. And what we did, this is some is progress I can advance. It is been adopted by the European Commission, is we have to create what we call the wheel of sustainable for electronics energy materials. What this means is when I started looking at this, I have to take care with the eco-design, which means it started how I designed the needs that I need, and from this point of view means that I have to select sustainable raw materials and how I can process it using as much as material as possible. And then I have to look that these materials that I want to manufacture, they should be biodegradable. And this is the strategy that we have to look if we want to keep our world sustainable. And of course, this is in the side of materials and of producers. And on the other side, we have to look for ways to fabricate using minimum energy as possible. And of course, all what you are doing should be recyclable. And this is the wheel of sustainability that we did. But sometimes we have challenges, and I would like to share with you two things where my group have been involved. One is this one. Spielberg in 2004, it was not last century, it was this century. He asked to a bench of scientists, 20 or 25, I want to make a science fiction movie. What I should do it? And the guy said to him, okay, imagine someone that is able to communicate with the surface and which is fully transparent and he can communicate. This was science fiction. In 2004 was science fiction. And they created the Minority Report. You have Tom Cruise, this very famous movie where he tries to control. And when we saw this movie, I have to tell you, a couple of guys thought, I need a wide bandgap material. And the first idea is I have to go for gallium oxide-based materials or something like that. But gallium is very expensive. If I want to make something natural, let's try to exploit something else. And the idea was to start using bricks, metal oxides, which is a brick, a passive component, well known for passive applications, and try to transform. And the idea is that these metal oxides, which we use to make bricks, at a nanoscale, they have different performances. I can modulate the performances of these materials at a nanoscale. Then I can make transistors. We have been doing the first full transparent transistor at low process temperatures. And this is where we introduce this oxide thin film transistor. This was with Elvira. And the idea was contrary to what Ideozone, that was the father of this idea, has had, because he published a theory paper in 1995 where he said that the metal oxides, the ionic materials, they have a great advantage concerning the covalent semiconductors, is that they do not suffer from positional disorder, because the figure of merit in electronics is the mobility. And this means that if I create disorder, it means that the mobility goes down, because I create a band tails where the mobility goes down. So I have delocalized and localized states in the band that this density of the fates will control the performance of my devices. And when you go to make large area devices, this is why people move to amorphous silica, because they could make it with uniform performances at large areas. People never thought that I could make out of a disorder material a semiconductor. I have this in memory. One of my supervisors was Neville Mott, and Neville Mott wrote a book in 1974 saying that it's impossible to control the performances of a disorder material as a glassy-like material. This is what he called. And in 1975, we appears with water sphere that if I control the density of defects, I could have a doping effect on this type of structure. It makes a revolution, makes all this display technology coming back. But the mobility of these carriers are very low, on contrary with the ones that we reach on metal oxides. Because as you have these s orbitals, it means that when you have disorder, the disorder does not affect the percolation of the carriers, which are electrons, and you have the oxygen vacancies as the source for electrons. So we have a perfect way to use a disordered materials, large area, and with exploiting high conductance. We did it. We got mobility is very normal to have it above 50 square centimeters per volt per second, which is by far very good, but is a limitation on the response of this type of devices. So what we are doing, we did the first full transparent and flexible display in the world, only using metal oxides from the contacts, the semiconductor, and the dielectrics. And this is under the frame of a project that we call ORAMA. And then today, what we try to go is from microscale to nanoscale, because the figure of merit on electronics, and we were able, and we are very pleased to say, this is the first large television based on OLEDs, and where we use as the active matrix these metal oxides. This is where our name is there. But you can see this is a transparent OLED display that really impacts on our lives in a very large way. But as I told you, one of the bottlenecks on this technology is the response time, which means the response, as you can see, depends on the mobility. This is the natural mobility of the carriers of materials. For instance, we thought that we could have a ballistic effect in graphene on 2D materials. We never could get this 1,000 square centimeters per volt per second in graphene. We are looking, trying to understand why we cannot do it, because theoretically this is possible. But anyhow, if you cannot match too much on the mobility, because you have a lot of constraints, you can change the length of your channel. And this means that you have a drain and a source, and you have the pathway of the electrons. As you reduce the distance, you make it faster. So this is a way where we can say that I have a saturation mobility that goes over, and this is where we have to go. why nanotechnology is very good, and why we have to go for 2D and 1D materials, even exploiting these metal oxides. We have also organics. I will not speak about organics. They are like leaves. They drop now in the autumn, always. But the other thing that you have to look is for what I told you at the beginning, is that we have to see how I can really have more and more faster devices. So the timeline goes down, and also the power consuming should go down. And this is the perfect match, is the Moore's law that we are applying on these new emerging devices, where you can see that we can really go. This is data that we took from published works, and you can see that, of course, we are on the right track, exploiting these nanoscale devices where they have faster response and also consume much less energy, ultra low power consuming devices. And for this, we are exploiting this type of oxide transistors, nanowires. This is the performances that we got on these nanowires and the transfer curves that we are doing. Today, we could make on this real techniques where I can integrate these devices full based on oxides, and we use 13 layers, and the PPIs that we can get is around 1300, larger than the silicon technology, which is around 500, 600. And this for augmented reality is fantastic, because I can integrate the new displays in my glasses, and I don't have opaque areas, because everything is transparent. And this is a milestone that we got it. And the other milestone that I would like to speak is also by exploiting our imagination. Rawlings is the lady that creates the Harry Potter. And on Harry Potter, when you look for this Harry Potter, they try to make the Daily Prophet. And the Daily Prophet is the journal where the idea was I could make a display out of the journal. And this was a fantastic idea that we promote. We could, why not make, as we have processing all these materials at very low temperatures, try to exploit paper for electronics. And we created this, and in 2023, the European Commission considered the two best innovators in Europe, which is Elvira, which is my wife, and the other one is Tesla. I don't know, maybe you don't know, Tesla also was a great innovator. When he appeared, it was at the same time as Edison. Edison is on back him all the power of America. And he said that all the transport of energy should be in continuous current, which he failed. Tesla was right, you see. And this is maybe what we lost as European. And cellulose is a sustainable natural source for groundbreaking applications. You can make the number of cellulose that we can fabricate per year is by far above what you need. The technologies that you use to process it is by far fantastic. And most of the paper, 75%, is recyclable. Can I functionalize the paper? And our idea, this is very important. In 2008 or 2009, we created this brand mark, is our patent. We create the green electronics for the future. 8 years before the sustainable targets of the European Commission. That's why I believe we may get a Nobel Prize, by sure. And because when we start working on paper, most of the people, our colleagues, they put only disadvantage, not sustainable, how we can reproduce, how we can maintain, how we can keep it. But when we are speaking about this, we are speaking how I can make out paper, how I can functionalize the fibers and created and generated CMOS devices on paper and starting thinking how I can use it on smart labeling displays. And of course, this is something else very important. And on this type of cellulose that we start for more than 16 years developing, we have a lot of things to do. And today is a critical area of our development, well recognized by the European Commission. We have paper electronics as a program inside the European Commission. And this is what we can do, how we can exploit the cellulose nanocrystals for photonic films. And this is how I can protect and really improve the quality of my surfaces. How I can exploit either the natural cellulose or the bacterial cellulose, making nanocellulose. And one of the things that we are really doing is to use paper as a structure for the membranes and with something else, which I cannot tell you now, to make the lightest battery in the world. I belong to a consortium, a European consortium. We are trying to develop the lightest, and we are using paper, nanocellulose. It's not paper, it's nanocellulose. And most of the components that we are, and also we are exploiting the electrodes using graphenizing the surfaces of the paper. And this is something very important, because also I can make it biosensors on paper. And this is very important for environment impact, because the ones that we have today based on silicon technology is very hard to recycle. You spend a lot of money to recycle a lab on chip, while here you just burn the paper, because you can make microfluidics. I can sensing the elements on the paper, and I can strategically try to understand better the paper. And one thing that we did is, this is our last project that we did, you can functionalize the fibers. And when you functionalize the fibers, when you cross two fibers, you define a device. And then I can wave the structure, and we make the first full textile display based on this technology. 40 centimeters by 40 centimeters. We did this with LG. And of course, this means that in the near future, as we are able, of course, you have problems of technology, but you can see the performances of the transistors that we are making on these fibers is really very important. But when you look, you can see that you have the yield. Okay, it's just a problem of engineering. It's not 100%. Not all the spaces are communicating, but the principle, which is what as a scientist should do, is working. And the point is that this is my dream. Today we are here with no natural light, because we need light. Even when we go to our computer, you can see that typically today we would like to interact with the display, with my display, because this is the natural way to do. And light, we should have light coming from our walls, which is not the case today. In the future, as we have had 30 years before these paper walls in our houses, we may have paper lighters that we can control the illumination in a natural way of our lives. And we believe this is done. And what we created the first infrastructure in Europe. We have people here, and that's called Emerge. We are closing now the first 4 years, but I think with outstanding results. We are getting more than 1,000 visits to the lab. Excellent projects that is being developed along this. This is later, so. But we are closing now by the end of this year. But this is emerging technologies that we are impacting, and we may go further, and we try to impact this type of infrastructures in our strategy of our future. But along this, what we did is, of course, we cannot uh, disregard what we have today. Silicon is silicon. When you go for ultra-fast devices, we need silicon. And when we need silicon for doing all this process, mainly at a nanoscale. When we go speaking about nanoelectronics, 1D, we need this. This is a lack of information that we don't have in Europe. You know why? Because we export everything to Asia, because we think that was the best way. We have the brains we could control, which is absolutely wrong. The knowledge is where things are made. There are no masters that control the masterminds. But we created this type of infrachip structure that started, is 1 year old only. And this infrachip comes from the combination of two ideas. Tyndall is a very well recognized, CA is a very well recognized. And so I told them, why we don't try to combine and make complementaries, nanoelectronics with emerging technologies. We did it, it's working. I say, while Emerge was in the 2nd division, because the budget was smaller, much less than this one. This is in the 1st division. And the idea is how we can combine the king of the king with these emerging technologies and identifying clusters of application that we can do. And at the end, I would like to make some propaganda of the Journal of Discovery Materials that I'm the editor-in-chief, the set of books that we publish. And also we created a startup that is devoted on paper electronics. They are now on the market. Ocean is now exploiting their own results for controlling the goods. And I would like to finish with two dreamers of our future. One is Victor Hugo, that says there is nothing like a dream to create a future. And this is why we are here, is exploiting our dreams of the future. And the other thing that I would like is a second thing that is maybe harder for Europeans to follow. I will just tell you a story. I have had the honor to have as one of my supervisors, Sir Neville Mott, and he used to say in the 70s of the last century that when you go for science, the Americans put the money to get the results. The Japanese are hard workers. They work dynamic. And as Europeans, we spend all the time discussing to who belongs the ideas, which means this is a strong commitment for a reform that is very important to use it for the good, for our good and our future. Coming together is a beginning. Staying together is progress, which is very difficult. You may feel here that you have some problems here. And working together is a success. This is what we need, is not only join people, progress, but work together, making networking, and this is what I think is very important. And I would like just to finish with African proverb that I'm very glad, because nature is using this proverb on this portfolio that they are doing. We have had a webinar with Magdalena, which is the CEO of Nature, and this is a European proverb. Maybe Ford took some information from here. Is if you want to go fast, go alone. If you want to go far, go together. The message is the same. To get exit, to get something consolidated, we need people. So thank you very much. I would like just to pass, if it is possible, for you to have an idea of my laboratory.
A forefront laboratory filled with advanced equipment and focused researchers. Since 2006, I3N has become a leader in innovation and research, combining the expertise of CENIMAT at Nova FCT and FSCOSD at the University of Aveiro. Our mission: to drive the discovery, development, and deployment of nanotechnologies and advanced materials, enhancing quality of life while promoting societal, economic, and environmental benefits. At I3N, experts across materials science use cutting-edge labs and equipment covering materials synthesis, device fabrication, and characterization from macro to nanoscale. Researchers have access to a powerful local computer cluster and larger Euro-HPC facilities for precise nanoscale modeling. In clean rooms, we advance flexible electronics and solar cells using state-of-the-art deposition tools to create nanostructures like oxides, graphene, and carbon nanotubes. Advanced patterning tools define nanometer-scale features on flexible substrates using technologies like direct laser writing and substrate-conformable imprinting. Our custom additive manufacturing setups for metals control microstructure and properties, producing stronger, more resilient alloys. We also use solution-based methods to prepare a range of inorganic materials, including single crystals, polycrystalline fibers, and nanoparticles. Low-cost techniques for thin films include spin coating, doctor blade, and spray coating. We excel in printing technologies for supercapacitors, energy harvesters, and biomedical devices. Laser technology enables physical and chemical modifications on substrates, creating laser-induced graphene for biosensors and digital microfluidics. Our infrastructure supports multidimensional characterization from materials to systems. Our advanced scanning transmission electron microscope offers unparalleled nanoscale analysis. We have multiple scanning electron microscopes for various research needs and atomic force microscopes for atomic-level analysis. X-ray photoelectron spectroscopy provides surface analysis of materials, revealing chemical states and elemental composition. Our nuclear magnetic resonance spectrometer and relaxometer analyze porous and soft materials for diverse applications. Optical characterization labs analyze bulk, thin films, nanomaterials, and devices using advanced spectroscopic techniques. Photovoltaic devices are tested in our dark room with solar simulators, spectral response systems, and a lifetime tester. Electrical characterization facilities cover material transport properties to circuit analysis, ensuring thorough assessment of nanogenerators and pressure sensors. At I3N, we lead in developing new materials for various applications, driving innovation and shaping a future where advanced nanotechnologies revolutionize industries and solve global challenges.
So, thank you very much for your attention.
Thank you for this very interesting talk. Now is time for some questions, please. Yeah.
Thank you very much for this visionary talk. So one of the things that you have really advanced is the fact that you get decent properties at room temperature. If I understand, there is any heat treatment in the case of the paper electronics. Is there any limit on the annealing temperature and so on that you could improve the mobility, or is not need to go in this direction?
And at this moment, as we are making for commodities that are to be disposable, we don't care about this. We need more for encapsulation processes. But we have rapid annealing and UV curing where we can really improve and enhance the performances by indirect. So this rapid curing is what we are exploiting. Most of the people that now are working on the so-called paper electronics are doing with success.
The improvement of the properties is very strong?
It improves because on paper, on this nanocellulose, one of the things that we have is like a MOS because it's a porous structure. And when we go to exploit this paper and how I can functionalize the fibers, first of all, the fibers are a dielectric. How I can improve this performance and I can realize that I have a step coverage of the surfaces uniforms. And of course, if I have micro cellulose, means that I can have large pinoles in my structure. If I go for nanocellulose, I have small pinoles in our structure. So the idea is to move to nanocellulose. So when we speak about this nanophotonic crystals is because if I get crystals at a nanoscale, the performances of what I'm functionalizing are by far better.
Okay, and then a second question. So usually when we have new innovations, development, and so on, you can do either to create new products or to substitute already existing products. In your case, what is your vision? You actually are creating new products which not will decrease the amount of products that already exist, or are you able to really modify what is already existing?
Right. The first tendency,
The future, I mean.
the picture that we have to look is how I can make things that today exist sustainable, how I can create the new products. I can tell you, when we make the first transistor out of metal oxides, I went to Siemens saying, we have something which is fabulous. And they told me, forget it. Our business is silicon. This, I don't know what it is. We work with silicon. And at the same time, we were frustrated. And then it appears the Koreans to speak with us because they heard, and we make the patent with them. And it's a success. So sometimes, and it was to solve a challenge. The challenge was how I can have large area displays responding in a better way. And when I introduce the OLEDs, means that I need more current. And the people that use the amorphous silicon technology, they have to have circuits to enhance the current on the OLEDs. And here, this is not necessary because the current, the saturation current that we have is by far 2 or 3 orders of magnitude larger than what we have with amorphous silicon. Therefore, it means that I solve an existing problem. This is what we did. Even now with the paper, where we are getting more success is for biodiagnostics because it impacts better on the people. It serves a need mainly to control the water pollution, to control the agriculture process. We have a project running here with, and even now, we for instance, now it closes a call on the Pathfinder. They got 2,500 applications. They approve only 40. One is ours. And the idea was just to promote on paper an integrated sensor for agricultural purpose. Okay, we have to present some ideas and some credibility how to reach this pipe. But this is what we try to generate. We are pushing to the limits our colleagues. We are proud because we are a small laboratory and we have 12 running ERC grants. And for me, as I was a member of the Scientific Council of ERC, is the best scientific council in the world. We generated and create science per se. And we think out of the box. And we have very good examples with vaccines. The 2 vaccines that save millions of people came from this project, this program. So what we try is not to make copies or make business as usual. Try to push your students to imagine and to create the future. And of course, we have to have a balance. We have the people that make the follow-up, what the others did. But for me, is in the middle of 5 or 7 guys, I need to have one that is creator. Otherwise, I will lose. For instance, we created an idea to generate it now a new photovoltaic devices where we try to band engineering the gap, where we try to create some shallow and deep states. And by this way, as I can respond, have the shallow and deep states to respond, means that I can enhance the rate of capture of the photo. And then I enhance the performances of the photovoltaic. This is an idea, no one did it. So this is how I can substitute the tandem structures. But here again, what we try to make is, I think I discussed with you in the past, what we call the solar refineries of the future, because we try to integrate this energy to generate the energy that I need, green hydrogen for the future. And we got an ERC grant on this that is running now. It's an idea. We fight by 3 times until we got it.
Thank you.
Another question?
From the point of view of ecology, we need to do something rather fast in the coming years to reduce the power consumption, because there is an emergency. The climate is an emergency. So are you optimistic that we will manage that, or we are already too late because there is still a lot to the technical development that is
I'm
needed?
very positive about this. There are something. I saw a movie when I was young. Was a spy that came from the Gaulle with Yul Brynner, and it was all the action was between the border of the democratic German and the Federal Republic. And the guy said, when they have been exchanging spies, the guy from the American side said, "Come on, we are sending someone that knows a lot of secrets, American secrets." And the guy said, "No, come on. How many years he lived in USA? 10 years. So he is contaminated with the poison, the American poison." This is the same. You cannot take the comfort of the people, but you have to look for actions, how I can keep the comfort and reduce the energy consuming. So the strategy is not to go for atomic energy. Of course, I'm against it, but is you have to rethink it. First is a cultural program. You consume too much energy, maybe 20 or 30% of energy that you consume are waste. And then means that we can rethinking this. I will not say that I will put a guy with 90 years old to travel and walk alone. No, what I'm saying that we can use other ways to move ourselves, and we can try to think how I can use these sustainable processes where I can use much less energy to produce the materials that will supply the energy that I want. And maybe green energy, the green hydrogen could be a good solution if we can combine photovoltaics and make these refineries. And then I can make a sustainable world. So my hope is to give welfare and comfort to the people. That's what I say. We work in favor of the people. It's not to cut the people or to create an elite, and this elite is the only one that can survive. No, I'm fully open that, first of all, educate and have a better culture. Then I know that we will find the solutions to use ultra low power consuming and to reduce the way how we consume energy and how we can move. I don't want to go back 100 years and say I will work with a horse. No, there are other ways. And one of the ways of the future, I'm completely, not now, it's not still, but the electrical car of the future, where it could be sustainable with very low weight batteries, is the solution. Because I can control a lot of things about the explosions that we have, about these accumulations that we have on the oxidation. And if I have a lighter battery, then means, and if I can convert and store the energy coming from the sun, what do we need more? We are in the even.
Any other question? No? Yes, another one.
So again, very long in the future, what is the limits on your view of the performance that you can achieve with this? Do you have already some idea in mind?
Some years ago I said, sky is my limit. Now I think beyond the sky. There are no limits.
There are no limits.
Our imagination is quite creative.
Good.
Yeah.
So you've been very much involved in building this community in Europe. So how do you see the position of Europe? Do you think Europe has a future in this? So we are very much fragmented in efforts, in priorities, in funding. So the EU funding is only 10% of the funding of science in Europe. So do you see the possibility of merging efforts and doing things which are more coordinated than now?
I'm quite confident. This depends on us, depends on the way. First of all, I'm full European. I believe in Europe, but I don't believe in this Europe, because this Europe is a lot of fragilities and has to change the rules as it is. And we need more money. I just discussed with Xavier. I came from China. I will be back in China. They are making the new quinquennial program that will start in May next year. And the logo of Chinese is science and innovation for the prosperity of China. This is, so you see how they really trust on science. And most of the things that they do are based on that. We need to have the same thinking in Europe. But when you go to think in Europe, of course, I know that we are in a war problem, but before the war, we have also the same problem. And there are a mistake that we make it. And as advisor, I'm one voice, but I believe most of people, I'm trying to capture most and more people. We need to prove that what we do serves the people. And this is something that we are not able to do so far until now. And what I mean by this is the following. When the Commission gives money to you, when you close your project, no one makes the follow-up of your project. And each year, the Commission puts 1 billion euros. It's not 1 million euros, it's 1 billion euros that are thrown away. And they don't capture. One of the things they said, you should try to look for it on patents and so on. They said, no, we cannot make money out of the. So we are killing, because this is a source that is open and you are drying it. So this is one of the problems. I think that we have to rethink the strategy of Europe. We have to make the follow-up of the projects. I could see EIC on the make something like that. It was a cooperation that we did between the ERC and the EIC when it was launched, because the idea of EIC on the transition is to pass the ideas, 3 or 4 guys, not one, have had for industrial product. And then you get this, synergy at ERC is more or less the same, is how we can combine efforts to create something that will impact on our progress. But then we need to make the follow-up and need to see what are the revenues that we are creating. No one in Europe, as far as I know, did this accountability. We are just looking how much money we put on science, but how much money out of science generate prosperity in Europe. So this is a dimension that we have to discuss if we want to be credible. If you look for the other programs, I don't speak about the USA because today USA is not a good example, but if you look for the Chinese, where exists this narrative in Europe that they came to Europe to make copies is absolutely nonsense. They have outstanding talents. If you go to Nature report, I can send you the link, you see in the 3 first positions, now in materials, engineering, and chemistry is China. And this is a report from Nature from June this year, not from the past century. So it means that they are really pushing. Why this is easier? Because they have a lot of people. For instance, they have hundreds of millions of talents, and they make a very restrict selection of these talents. And in Europe, we don't have talents to generate the materials that we need. We don't have talents enough for the prosperity that we think for the future. So we have a good opportunity to bridge, to make this type of alliance, to make networks. I have to say that I'm now in a good position, good shape with China, because I won this year the highest prize they give to a foreigner, and they look for us as with respect. In Europe, sometimes we don't have the respect between us, and the idea of them is how I can create prosperity, but they bet on you, but they ask of you to make it happen. Otherwise, you are killed in the sense that your career is completely destroyed. So they put money, but they want to see the results out of it. And we need in Europe, not to be so drastically, but to make the follow-up. It's very simple. What happens with the money that I put in the projects? Ever you got the feedback of this? No one. And this is something that if we do this, people start thinking, and we have to disclose the good things that Europe is doing in favor of our progress. No one does this. We just think how much money I can collect from the Commission, and that's all. No, we have also to ask the responsibilities for the Commission, what you really generate in favor of the people.
Well, thank you. I think that we have to stop here. Thank you very much for this excellent conference and very interesting. And thank you to everybody for coming here at the Royal Academy of Science of Barcelona.
Thank you.